Welcome to the lecture. In this lecture, we are going to solve LPP by graphical model. Uh, Maxima is that equal to 3x1 plus 4x2 subject to two constraint and the non-negative restriction x1 comma x2 greater than or equal to 0. Okay, the solution is obtained by following four steps. Step number 1, we are going to find out 2 points on each of the given constraints. Okay, let us consider the equation number 1 as an equation to find out such points x1 plus 2x2 which is equal to 80. Okay, if we assume x1 equal to 0, then this equation number 1 becomes 2x2 equal to 80, x2 equal to 80 divided by 2 equal to 40. Okay, it shows that the 0 comma 40 is a point on the first line. Okay, next let us assume x2 equal to 0, then equation number 1 may be written as 4x1 equal to 80, then x1 equal to 80 divided by 4, x1 equal to 20. Therefore 20 comma 0 is a point on the same line. Okay, next let us consider the equation number 2 be 2x1 plus 5x2 which is equal to 180. Let us find out 2 points on the line using the same process we done in the first case. If x1 equal to 0, then 2 becomes 5x2 equal to 180, x2 becomes 180 divided by 5 which is 36. Okay, which is 0 comma 36. Okay, next if x2 equal to 0, then equation number 2 becomes 2x1 equal to 180, then x1 equal to 180 divided by 2, x1 becomes 90. Which is 90 comma 0. Now using these points we have to plot the lines using the points. We are going to plot the lines in a graph sheet. Okay, Okay, let us first represent it is an x1 axis. It is to be x2 axis. Given that all the feasible solutions are in the first quadrant, oh, that's why we are only considering the first quadrant. Okay, the first line we can write or represent by 2 points 0 comma 40 and 20 comma 0. Okay, we need to consider which is point 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, and 80. Okay, the first point 0 comma 40. 0 comma 40 is a point in this place. Also 20 comma 0, it is a point inside. Okay, let's draw a line. Okay, it is the first line. Okay, it is given in the less than or equal to condition. That's why we are consider this portion. Okay, we need to consider first line represent these points. Let us represent the line number 2 by using these points 0 comma 36 and 90 comma 0. 0 comma 36, 0 comma 35 here. It is 36, 90. Let us connect these 2 points by line. For the equation number 2, let us draw the region. Okay, all the lines, all the region below. Let us identify the common portion, which is this is our feasible region. It's like a little clumsy. This okay. The region bounded by the red line is feasible region. Okay, let us identify the corner points P, C, and D. Here A is the point which is 0, 0. B is the point which is 20, 0. Here we don't know about the point C. Okay, we already know about the points D, which is 0, 36. In step number 3, let us identify the intersection of these two lines, which is C. Okay, let us this intersection of the first line and the second line. Let us consider these two to be an equations. Okay, solving these two, we get from the point C. Okay, 1 into 2, we get 8x1 plus 4x2, which is equal to 160. Equation number 2 into 4, we get 8x1 plus dx2 equal to 720. If we subtract these two, you will get minus 16x2, which is equal to minus 720, 160, minus 560. The next two, which is equal to minus 560 divided by 60 minus 6. cancel. 56 by 16. Which is 35. Then x2 equal to 35. Okay, we substitute x2 equal to 35 in one of the equation. You make it 4x1 plus 70, which is equal to 80. 4x1 equal to 10. x1 equal to 10 by 4, which is 5 by 2. Therefore, the point C is 5 by 2 comma 35. 5 by 2 comma 35. Okay, last step. Step number 4. What is our motive? Our motivation our motivation is to finding for what value of x1 comma x2 like okay inside this region it optimize our objective function. That is our question. In order to find out such point, let us make another step. Step number 4. Points objective function, value of the objective function. Okay, here the corner points are a equal to 0 comma 0. Here the z equal to 3x1 plus 4x2, 3x1 plus 4x2. Okay, at this point this function have at this point is z equal to 3 into 0 plus 4 into 0, which is 0. The value at the point is 0. At B point, here B is 20 comma 0. Okay, here the value of z equal to 3 into 20 plus 4 into 0, which is equal to 60. Value to be okay. Next C, just now we find that which is 5 by 2 comma 35. Okay, this point becomes z equal to 3 into 5 by 2 plus 4 into 35, which is equal to 15 by 2 plus 4 5s are 20. 140. Okay, which is 147.5. Then the last point, which is T, which is 0 comma 36. Okay, here the value of z equal to 3 into 0 plus 4 into 36. Okay, its value 144, which is 144. Okay, what is our motivation? Our motivation is finding the maximum value. Okay, here this in the feasible region, the point 5 by 2 comma 35, this problem have the maximum, therefore the optimum solution of the problem is x1 equal to 5 by 2 and x2 equal to 36. Moreover, the maximum value equal to 147.5. This is our optimum solution. Thank you. That's all from this lecture.